Okay, let us start the next topic of catalysts. Inhibitor or negative catalysts. Those catalysts which decreases the rate of reaction is known as inhibitor. For example, in the conversion of this chloroform to phosgene gas, if you use as a ethyl alcohol as a catalyst, so this ethyl alcohol catalyst act as a negative catalyst and it will decrease the oxidation of chloroform into speed of oxidation of chloroform into phosgene. Next is another topic is promoter. What is promoter? This is a very simple term that with catalyst, if we are adding some other substances and another substance which increases the activity of catalyst itself, in absence of catalyst, that substance is not going to work at all. But in presence of catalyst, this new substance which will add it will increase the rate of reaction. It will increase the activity of catalyst. That's known as promoter. Like those substances which increases the activity of catalyst are known as promoter. For example, in formation of ammonia by Haber process, we are adding iron. Iron is acting as a catalyst, and molybdenum, which is acting, it is acting as a promoter. Because if only we'll add molybdenum and iron, if we'll not add it, then there is no any work of molybdenum. Molybdenum only increases the activity of iron. So in this case, iron is acting as a catalyst and molybdenum is acting as a promoter. Now coming to the types of catalyst. Catalysts are two types. One is homogeneous catalyst and another is heterogeneous catalyst. Very simple. What is homogeneous catalyst? Like homogeneous catalyst, if in a particular reaction, reactant and catalyst are in the same phase, then it's known as homogeneous catalyst. For example, sulfur dioxide gas reacting with oxygen gas and forming sulfur trioxide in presence of NO gas. So here sulfur dioxide, oxygen and NO, all these three are in gaseous phase. So reactant and catalyst both have, all of them have a in same phase. So it is known as homogeneous catalyst. Similarly, when this sucrose on hydrolysis convert into glucose and fructose, and here we are adding acid as a catalyst. So acid is also liquid, and this one sucrose solution and water, both of them are in liquid state, in aqueous state or liquid state. So simply you can say that reactants as well as catalysts, all these are having in the same phase, then it's known as homogeneous catalyst. Now this homogeneous catalyst, these catalysts function on the basis of intermediate compound formation theory. What is this one, intermediate compound formation theory? That means when this reactant first of all react with catalyst and form a reaction intermediate. This reaction intermediate then again react with another reactants and then finally form the product. So these catalysts function on the basis of intermediate compound formation theory. According to this theory, catalyst first react with one of the reactant and form the reaction intermediate. Now this reaction intermediate is unstable in nature and it will further react with another reactant and finally form the product. So this is the homogeneous catalyst worked on the phenomena of reaction intermediate formation concept. Now what is heterogeneous catalyst? Heterogeneous catalysts are those catalysts in a particular reaction, reactant and catalyst are not in same phase, they are in different phase, then it's known as homogeneous catalyst. For example, like we can take a very simple example like nitrogen H2 react and form the ammonia gas, and we are using iron as a catalyst. So you can see here nitrogen and hydrogen are in gaseous phase, but iron, which is used as a catalyst, it is in solid phase. So this is the example of heterogeneous catalyst. Heterogeneous catalysts function on adsorption theory. What is this adsorption theory? Look at here. Adsorption theory means, like you can see here, this is the catalyst. There are surface area of the catalyst where many binding areas are there, free valencies are there, or molecules are unbalanced, surface molecules are unbalanced. So first of all, they will adsorb reactant molecule at its surface. First is adsorption of reactant molecules takes place at the surface of catalyst. Then this is indicating the A and B are the reactant which already adsorb at the surface of catalyst. Now this A and B, they will react and they will form activation complex or reaction intermediate. You can say that this is a quite unstable. When they will form the product, this product formation matlab reaction between A and B is already taken, then this is already converted into product. This product then get dissolved from the surface of catalyst, so that the surface of catalyst will again free for the next phase of adsorption. Like we can represent it in 5 step this adsorption theory of heterogeneous catalyst. Number 1, step 1, reactant molecule like A and B are the react, they will get diffused with each other, they will mixed with each other. Now in the second step, these reactant molecules will get adsorbed at the surface of catalyst. Now in third step, formation of product takes place via formation of reaction intermediate or activation complex. Then in fourth step, desorption of product will take place. That means the product will come out from the surface of catalyst. Then in the fifth step, this product will diffuse away from the surface of catalyst, so that the surface of the catalyst will be available for the next phase of reaction. Now enzyme, we are going to discuss about the enzymes. What is enzymes? As you know that it is also a catalyst which is basically acting as an, it is a catalyst which are basically acting as a catalyst for many biochemical reactions. So we can define it. Enzymes are nitrogen containing complex compound which catalyze the biochemical reaction. They are highly specific and highly efficient. What it means by highly specific and highly efficient? Like you can see here, we'll discuss it what it means by highly specific and highly efficient in the characteristic properties of catalyst. Now you can see for example like glucose when converted into ethyl alcohol and carbon dioxide in presence of the enzyme that is known as zymane. So zymane is a enzyme which is acting as a biocatalyst for this biochemical reaction. Same way, another example, lactic bacilli is another enzymes which is converting milk into curd. Now mechanisms of enzymes. Mechanism of enzyme, generally it works on lock and key mechanism. What it means by lock and key mechanism? They say, you know that here enzymes are quite specific in nature. It means that that's why it is told that it works on lock and key mechanism. Like you know, a particular lock will be opened by a particular key. Another key cannot open a particular lock. Exactly same way, a particular enzymes will act as a catalyst for a particular biochemical reaction. Like here, zymase cannot act as a catalyst for the conversion of milk into curd. Zymase is fixed for this reaction only. Exactly, lactic bacilli is only for this reaction it is acting as a catalyst. It cannot act as a catalyst for any other reaction. That's why it is told that enzymes are quite specific in nature and they will work on lock and key mechanism. What is this lock and key mechanism? Like you can understand here, like in step 1. In step 1, enzymes bind the substrate to form the complex. Like this is the enzyme and these are the substrate or reactant. When they will come to in contact with each other, they will form a enzyme substrate complex. Now this enzyme substrate complex in second step they will convert into enzyme product complex. Okay, and now in the third step this enzyme product complex decompose into enzyme and its product. So this particular enzyme will just join or attached with this particular substrate. It cannot attached or it cannot join with another substrate. That's why it is told that it works on lock and key mechanism. Now coming to the characteristics of enzymes. Characteristics of enzymes.